I've felt strongly about this subject for quite some time. It's something that doesn't get talked about very often in the academic world, largely because people in the academic world don't know the world outside of academia very well. Not always the case, but often. And I certainly didn't either when I was going through my, my grad school and postdoc experience. So I actually, the spokesman of the Youre experiment that I had done my postdoc with, and I were chatting about this at one point, and back in 2012, I could kind of give him a hard time about some of the stuff that they were doing I didn't like. And to his credit, he invited me to come to NIU, and they actually, unlike Andrews, they paid for me to come out and, and present. So a little bit about my background. I have BAs in physics from Andrews. I was here until '93. One of the, there was a couple of things I did interesting here. I worked with Mickey Kutzner doing some work on astrophysics stuff. I think I may have had a little bit to do with some of the atomic stuff you were doing at the time, but I think it was mostly Dave that did that at the time, not me. But we definitely did some really cool astrophysics stuff with quasars and trying to see if you could see evidence for a closed universe with that. I also got to spend a research semester at Lawrence Livermore Lab with, do they still have that program? Yeah, I don't think Livermore has it, but Argonne certainly has it, and I know the physics majors still go and do it. And it was a really cool semester to spend there doing some research stuff. I did some work with fusion power plant, fusion reactor designs, which, as my advisor there said, those have been 20 years away for the last 50 years. And now it's even farther since then, so yeah. I did my PhD working at University of Wisconsin. I finished that end of '99. I actually defended my dissertation the day before Thanksgiving in 1999. It's definitely a day you remember. I did research both at CERN, at the Aleph experiment, and at DAISY, which is in Hamburg, Germany. CERN is typically more well known. That's in Geneva, Switzerland. The Aleph experiment was on the LEP collider there, which was an electron-positron collider. And then DAISY, there was the Hera accelerator there that did electron or positron on proton stuff, mostly looking for proton structure measurements. But my dissertation was actually the other way around, using the proton to probe into the photons that would come off an electron and actually see a photon can act that it has structure. So my dissertation was a measurement of photon structure as it was more virtual, which is basically a neat little confirmation and detailed way of looking at the Heisenberg uncertainty principle. So that was pretty cool. It was actually the first measurement anyone had done showing that virtual photon structure diminishes as a photon gets more virtual. That would be an interesting lecture all by itself. But anyway, it was we got to be the first ones to actually do that. That was my dissertation research, very exciting. Then I went on for a postdoc with Brown University. I was working at the Youre experiment at Fermi Lab, so this is proton antiproton collisions. Oh, I forgot to say, at DAISY, my group that I was part of was responsible for building the calorimeter first level trigger. So in particle physics, I don't know how well everyone knows particle physics, mostly math and physics majors in here? Yes? Yeah? All right. So then I don't have to, you know, be quite as careful. You guys can catch up. So the work in particle physics, you have these huge experiments. I mean, they're the size of a fairly sizable building, and they're just packed with electronics. And so you have to do, every group is, you don't just get to get at the data and do cool stuff with the data, right? That's what my dissertation was doing cool stuff with the data. But you have to do service work and actually build the experiment if it hasn't been built already, or if it has been built already, you have to maintain the experiment. You have to keep fixing it, improving it, whatever. And so the group I was in was responsible for the calorimeter first level trigger, which was really bleeding edge electronics, and still kind of is, even though that was back in the 90s. We were actually running a 10 megahertz clock in our clocks, but we had 10 million beam crossings per second, and we were sampling the data from every one of those, and there was about 250 kilobytes of information that had to be looked at for each one of those. So how do you do that? So it was a really interesting challenge, and this is the beginning of where, In your undergraduate, you're doing lots of problem solving. So that's your first training. Then you start going to grad school, if you do go to grad school, and you start having to like work on electronics, understand it from soup to nuts, right? I mean, we were designing the electronics, soldering stuff together, then going and building drivers for this stuff. Then you had to do all your analysis stuff, which meant writing code. You're very comfortable with electronics and computers and anything to do with like IT-like stuff. That went up even more when I was a postdoc. I built the data acquisition system for the D0 experiment. So this was, you know, pulling in huge amounts of data from this big experiment and getting it to a computer farm so that people could, so that you could do your third level analysis before you figured out what to write to tape. And to do that, literally did everything you can possibly do in IT. And in the physics world, you kind of have to. In the science world, we don't have so much money to go hire 20 people to do something. Instead, one person does it and figures out all 20 parts of that capability that have to be built. So my analysis work there was on electroweak physics. I was in the Tevatron working group. Tevatron was the name of the collider. And we published the most sensitive, at that time, measurement of W gamma cross sections looking for anomalous coupling. So anything non-standard. We were essentially looking for non-standard physics and didn't find any, as is usually the case. I've been working at Bank of America since 2005. It's a rather long story, but it was very surprising left turn into the non-academic world. I had always intended to be a professor. I wanted to be a professor. My parents are professors, their parents were teachers. It's definitely the family, right? And that was what I had always intended to do. But yeah, I'm not doing that. So what happened and how did that happen is a pretty interesting story. So the story is, you know, I've worked all across the company now, and in fact, this is a little out of date in terms of what I do. Now I'm actually working at the company, helping drive the policies for the whole company on how we are automating and modernizing how we do software development. Something that often isn't realized in the popular media is companies like, well, any company these days is an IT company. Banks especially, but everything is almost primarily an IT company. And banking, if you think about it, is almost entirely IT, right? How much of your banking actually involves physical money? Not that much. It's mostly about electronic transfers and things like that, right? So banking actually is very much an IT business. And at one point, and I think it's still true, we were one of the largest, if not the largest, software shops in the US of any business. Like, we're way larger than Microsoft, for instance, in terms of number of developers and how much we develop. So we've built a new, we're trying to modernize. One of the things big companies have a problem with is often will be sort of, it's hard to change, right? You have so much stuff, it's hard to change. The common statement is, you know, we're trying to turn the Titanic, and it, you know, doesn't want to turn. So it can be quite a lot of effort, and I'm involved with an effort right now to modernize how we do things. So automated build-in deployments. If you know what DevOps is, if you don't, you should know, because there's definite openings career-wise in the future of DevOps, where, you know, we really have automated everything from like the developer checks in code, and the next time a human touches it is never. It goes all the way through, gets tested automatically, gets deployed to various environments, gets handled, and unless there's a defect in the code, it'll end up all the way in production, having been fully tested before it actually even gets to production. And there's companies that have gone from, you know, say one deployment a quarter to 10,000 a year by doing this kind of thing. I don't think we're headed there. Obviously in banking, you don't want things changing multiple times a day. The other companies benefit from that more than we do, but certainly, you know, there are improvements there. Now, I'm not here speaking for Bank of America. I want to make that really clear. That is who employs me now, and you know, I try and be a value add there. So I will say a few things about what my experience at Bank of America is to help you understand the kinds of things that you can do elsewhere. Do not take me as speaking for the company. It's a much bigger company than me. Like we said, about 250,000 employees, I think, is what we're at now. I think we're around 50,000 developers. It's a big company, and I'm certainly not senior enough to be making any statements for the company. So, So I'm talking about, the whole reason for this talk is to talk about being, and is mostly focused on physicists, but I think mathematicians, math and physics are pretty closely related, and I think the attitudes and the skill sets that mathematicians and physicists have are pretty similar. So when I say physicist on these slides, I mean both, and I just haven't gone through and modified all of them. But physicists going out into, or hard science people going out into the academic world, or out of the academic world, bring a lot of unique things. So what I want to do is look at, what is it that motivates us, right? I still view myself as a physicist. One of the really important things when I made that transition from the academic world to the business world, I really didn't want to go. And it was emotionally difficult. And what made it easier was when I realized, oh, I'm still a physicist no matter what. Because guess what? Once you've had a physics or a math education, you're permanently warped. There's no way to fix it. All right? You are. You're different, and you always will be. And what are some of those differences, and why are they a good thing? So let's talk about why we get motivated. What do we like doing? Why are you a physics or a math major? You didn't choose this because it's easy. I'm pretty sure. All right? Because it ain't. If you chose it because it's easy, then you're a lot dumber than I suspect you are. It's not easy. So we like the challenge. We don't like doing easy things, right? We like working on interesting things, something hard, and eventually something cutting edge, right? You're not here because you just want to work on something boring the rest of your life. You want to do something that no one else has done. We like doing, we're a little smug, let's admit it, right? We know we can do things other people can't do, and we like that. And that's a good thing. We like to be, for me anyway, and I think most of the people I knew in the physics world and still know, we like feeling like we're expanding human knowledge, right? We're out on the edges and we're learning new things. Like I had to brag a little bit, hey, I was the first one to measure blah, 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 right? That felt good. I added something that no one else knew before. And we like to think we're making the world a better place. And this last point is going to come back. It's hard to get motivated to do hard things if you don't think it's actually going to make things better, right? And like I said, we'll talk a little bit more about that. So from an academic point of view, and I certainly always had this, the only real job path that I saw, and I think almost all of my grad student buddies were the same way, people I went to undergrad with as well. Certainly in postdoc, it was starting to be a little less true, but we still had the same idea that there was really one path. And that was into that sort of academic job, being a professor at a research university, maybe getting a job at a national lab and doing research. And the fact of the matter is, there aren't that many jobs a year. This is statistics from a little while ago, but these haven't changed. This is still about right. They may be a little bit off, but it's not very far. The actual number of jobs per year is not very many. There are a lot more PhDs granted every year, 1,500, than this small number. And that's just in the US. And when you're competing for a job in academia, you're not just competing with the US. You're competing with the whole world. Everyone wants to come here, right? This is where the good stuff is. So you can already tell from these numbers, and this number, which is just the US, you can already tell that your main path, even if you go get a PhD and do a postdoc, which I highly recommend, it's a great experience, and we'll talk about why that's such a great experience. But even if you do all that, you're probably going to have to find a job outside of academia. And I'm going to argue here that that's actually not only the mainstream, because most of the people are going to have to do that, but it's a good thing. And it's something you should want to do, or many of you should want to do, because there's huge pluses to it. So we talked a little bit about the pluses and minuses of non-PhD granting and working PhD granting institutions. But as you can see, I mean, the main point here is the vast majority of people who go and get a PhD or have an undergraduate degree are going to end up finding a job outside of the field. So why should you want that? Well, first of all, there's a rather large number of jobs per year you that are available in a non-academic world. I put question mark because it's thousands and thousands and tens of thousands. But another key point is it's an unsaturated job market. I actually just got off the phone. I'm setting up to do a presentation to one of the senior leaders in the company to talk about how to deal with finding talent. We struggle with it. We have open positions, we can't find good people. And that unsaturated job market has a couple of impacts. Not only is it easier for you to find a job, which isn't a good reason to tell you to go to consider that kind of job, because wait, we like doing hard things. We already said that, right? It's not because it's easy. The big plus there is make the world a better place. We talked about that before. If you go into academia, there are, we said, a few hundred jobs a year and a few thousand people wanting it. When I was applying, I did one round of applying for research professorships. There were 10 positions open in particle physics that were at research universities. This is what I applied to, 10 positions. I had an inside source at one of the universities who told me they received 300 applications for their one position. So there were about 300 people applying for 10 positions. Now, obviously that kind of makes you, I'm gonna beat them, right? But it's something that didn't occur to me until many years later. If I didn't end up in one of those positions, somebody really good was gonna end up in that position, right? I think I'm pretty good, I want that position, but if I don't get it, guess what? Someone really good is gonna be there and they're gonna be doing cool work. Maybe even the same work I would have done, probably, because usually they're hiring them for a specific kind of research. But if you look at the job market outside of academia, if you don't take it, if you don't bring your skills to that job, who is? And you have unique skills, and we're going to talk about what we bring as these kinds of people, us, bring to the market. And what we have is a unique value add that other people don't have. There's all sorts of advantages to the non-academic world. You know, I live in Colorado, I work from home. I leave the house when I want to, not because I have to. Now, that's kind of nice. I get to live where I want. I get to live in a beautiful place. My home office, I sit there looking at the mountains. You know, that's pretty nice. Pay is pretty good. You actually do a lot of mentoring and teaching. I've become a manager primarily because I love teaching, right? It's in my blood, I can't help it. And it turns out being a manager is primarily about teaching. And so you're pulling people in and you're teaching them. You're not done learning when you get your first job or your second job or your 10th job, right? You're gonna be learning the rest of your life. And if you're good at teaching, that's gonna help other people. So all sorts of advantages to it, but what I really wanted to focus on was what is it that we have to offer? And this is, to me, the most important part of this. You know, telling you that, yeah, there's jobs out there, yeah, you already know that. But what I struggled with, and everyone I knew in grad school, I actually, when I put this together the first time, I talked to everybody that I knew in the physics world, which is, 100 plus people, and asked them, their input on it. And by and large, people are like, yeah, we don't really understand what we have to offer outside of physics. Right? When you're working in the hard sciences, you feel stupid most of the time. This is something people don't realize outside of people who've done this. People don't realize that, you feel stupid most of the time. I certainly did. And you're always struggling, you're always working against the fact that nobody knows something or you're learning something for your first time. So you feel dumb, and so you don't really feel like, wow, what do I really have to offer? Why would anyone want to hire me? So what I wanted to, this is really what I want to hit on more than anything in this presentation is, what is it we offer? Now, one of my former bosses, actually, I asked him, what do you think of physicists? And this was his quote, and I was rather surprised to have such a clear quote. I mean, executives are not known for giving really clear statements, but he did, and he said, that physics minds are the brightest that there are. And I think it's true, right? You've come here, and well, as I said, once a physicist, always a physicist. You have a diversity of thought and a lack of fear of the unknown. You do a lot of homework, and it's always different. and you're getting thrown different stuff at you. And this is true for mathematicians just as much as physicists. You're always learning something new. You're always getting challenged. And quite frankly, you end up getting a little bored if you're not getting challenged with something and something new is coming. But that is completely different than the normal person. You all are weird. Because the normal person does not want to have to deal with something new. They want to kind of, you know, one of the things that absolutely shocked me when I became a manager was one of the guys that worked for me, we kind of set up what our vision was and what we were going to do, and then the team was just killing it. And I had nothing to do. I was putting my feet up, and I'm like, what am I supposed to do now? These guys are, you know, I would every now and then have something to do to like explain what we're doing or get a roadblock out of their way or keep somebody from annoying them. But for the most part, they were just doing it. I'm like, you know, I'm lazy. I mean, I felt bad, and I'm like, well, you guys are doing all this great work. You know, what should I be doing? And their response, very clear, and this has happened multiple times over the years. People who work for me constantly will say, no, you keep doing what you're doing. We don't want to do that. Like, that's nasty work. And what it is it's the unknown. It's the something weird is coming. How are we going to handle this? What is our plan? Somebody's asking a question. I don't understand what their question is. How do you deal with that? And people with a hard science background, fear of the unknown, what are you talking about? That's what we look for, right? So it's a big advantage coming in, and the business world is full of unknowns. They're not bleeding edge of human knowledge kind of unknowns, but they are unknowns. And just having that courage to be able to step into a weird situation that nobody's ever done before that has ever been there is a great example. I got hired at one point. I moved around different positions in the company. At one point, I applied for a job with my current boss. This was around the time I first built this deck, actually. And she had two positions open. One was working on environment support, which was what I had been doing, so I was applying for that. And the other one had to do with test data. So the data you use to test software. So you've written some new software, say, I don't know, handles, you know, savings accounts or something. So you need to have data to push savings accounts through that app and make sure it's doing what it's supposed to do. Well, I applied for the position because that's what I'd been doing. And she looked at my resume and said, you've done data stuff before. Like you said, big data, right? You've done data stuff before. We need someone to figure out how to handle test data. Well, the reason that they were looking for someone to do it is it's not one of the things that gets trained in your computer science department here or anywhere else. It's not really a trained expertise. Nobody knows what to do with test data. Well, you figure it out. Are you kidding? I love that. But nobody else wanted to do it. Like, I've been doing that since 2012 now. And I've never had someone challenge me on wanting to do it. I love it. But you know, everyone else is kind of afraid of it because there's no, like, I can't go find a textbook that tells me what to do. Or I can't find a web page that tells me what to do. It doesn't exist. I get to make it up. That's awesome. There's no one to tell me what to do. You know, and so that fear of the unknown, I mean, diversity of thought, coming up with your own solutions for difficult problems that no one else has ever done before, this line is huge in the business world. And it's something you do every day, and you will continue doing as you go through your education. If you go on to grad school, it'll get more and more, and if you go into a postdoc as well, even more. And so while I'm sitting here arguing, you know, maybe academic isn't the mainstream, obviously academic jobs are great, and if you end up in one, that's awesome. But if you end up somewhere else, you are bringing something to the table that otherwise would not be there. And that's one of those things. Analytical capabilities. All the homework you do means you're really good at problem solving, like really good. Again, you don't feel it. You mostly are feeling stupid, right? I always did, right? That homework, I don't get it, whatever, pull your hair out, finally figure it out, thank God, now comes another one. You don't even have time to celebrate, really, right? You're just done and moving on to the next thing. That practice means that you can be faced with situations that need to be analyzed, and you're going to do the analysis without even thinking about it. I'm regularly in meetings where someone presents something, and I'm immediately like, wait a second, but that means this, which means this, which means this, that's going to be a problem, or that's good, or whatever. And I pipe up and I bring that in, and everyone's like, oh, that's such great, insightful, whatever. And I'm like, yeah, what do you mean? That's just normal thinking, you know? So that analysis, you will do naturally. You already do it naturally. And you will continue to build up that capability. And that's something my boss comments on all the time. Analytical skills. I'm actually supposed to be having my year-end review right now with her in this hour. But I figured I'd rather talk to you guys. And I know that's what she's going to talk about primarily. That's what she's said for years. Analytical skills. Now, I'm not that different from any other physicist. I didn't get a professorship, so obviously I'm not the top. So, you know, if I am like that, certainly you guys are too. And, you know, that's sort of very related to that next point about correlations. Just seeing relationships between things, right? That's, again, a lot of what you do in your homework. You're looking for, hey, I know this bit, I know this bit. If I put those together, I can do this other thing, right? And being able to put things together, see how they work together, is a huge part of what is needed in the business world. And again, stuff you guys train to do constantly. People with business degrees, people with IT degrees, they don't get this training. They don't get trained how to analyze. They don't get trained how to see correlations. They certainly don't get trained on how to use math and statistics and algorithms and logic. A little bit of logic for the IT people if they're taught how to code, although I've noticed that coding is not necessarily all that strongly taught these days in most schools. I don't know about here, but schools I've been in, there's not even that much logic there. And my current job, and this is very common thing needed, is, hey, we need some metrics to measure. We're trying something. We want metrics to measure how good that thing is. Is it working? How is it working? How much are we spending on it? What benefits is it giving us? And I don't know how to say this other than rather derogatorily, but my coworkers are terrible at trying to figure out a useful metric. They'll throw out a number and, oh, we're done, there's a metric. Well, what's it mean? What's the error on that? How accurate is that? What's it mean? How good is your data underneath? Huh? You know, they just don't know what they're doing with data or numbers or anything to do with math, statistics especially, and any sort of algorithm or logic, oh my goodness. And again, what are you training to do? That. And that's what's needed out there big time. So yes, this all basically comes down to being powerful problem solving. You guys are building those skills. You've already built a lot of them. You will continue to build more. And so that problem solving makes you an incredible single contributor type person in an organization. But it goes beyond that, because with that academic background, especially for those who go farther into it, but even at this point, you probably teach each other fairly regularly, right? You're helping each other. Hey, I know how to do this. Here, I'll show you how. Or I don't know how to do this. You show me how, right? It happens all the time. That's how we get through this stuff. That means you know how to teach. And as I said, being a leader of an organization, or even a small little team, is a lot about teaching and mentoring and helping other people be better. And I actually have gone in recent years, I don't do anything anymore. I call myself a do-nothing manager. My team does amazing work. And I'm teaching them and helping them, and you know, oh yeah, I get roadblocks out of the way, and I go and I do the sales job to the executives and whatever, but I do a lot of teaching. And you know, they're gonna do a presentation, help them do it better. They're trying to analyze something, help point them out how to do it. You know, that teaching becomes extremely valuable. So those two last things are really kind of the overall summary of what it is, but there's a lot of detail behind it. And you may not realize what it is you've got. I certainly didn't. And I know most of my peers didn't either. For me, what I have seen to be difficulties in trying to get out there into the non-academic world. In the academic world, people know what a physicist is, particularly other physicists, right? And it's been interesting, you know, my dad said something about how we hired a number of physicists. It was because we were telling our bosses about each other. And they got, and we said, yeah, my buddies are exactly the same way I am. Oh, can we get them too? You know, kind of thing. They didn't really know at the beginning, but a guy that I went to grad school with kind of paved the way. And then there was a second one, I was the third one, and there were a couple more that came after me. Actually, It's more than the 5 I said, because there were a couple I hired as well out of Fermi Lab. But you know, a lot of people are not really sure. So you can run into the problem of people not really being sure what you are. So what's really important is you need to know this list. What is it you offer? Because if you can get in the ear of somebody, every time I've actually gotten an interview with somebody to explain what I am and what I bring, I get a job offer every time. But getting to that point can be a little tricky. So you need to know how you're writing your resumes and writing cover letters and things like that, and playing the game, getting a phone call with somebody so that you can explain it. But you have to have this explanation down, because just saying I'm a physicist or I'm a mathematician, okay, so. But if you can explain what you bring, that makes a huge difference in the business world. They are always, every business I know is looking for good people, desperate to find good people. It is very hard to find good people. But they won't know you're good unless you tell them you're good. So you're going to need to understand what you bring to the table. Now, this is sort of a basic foundation of what you bring. Each one of you is different, right? You're going to have different things that you're good at. This teaching and mentoring, I actually think for my personal career, this one has actually been the most important part of the whole thing. Even when I was a single contributor, I found myself being a translator between two people who spoke perfect English, constantly. Communications and being able to write and being able to get up in front of groups of people and present is what has been the biggest thing for my career at the company I'm at now. So that's for me.
But that's because he's related to a preacher.
Well, it's probably true. It is funny how often I feel like, wait a second, this sounds an awful lot like a sermon. I probably should dial that down.
How you learn to talk by giving presentations right here.
Yeah, absolutely. Well, actually it wasn't here. It was up in what is now your office.
Ah, yes.
So when I was here, and I think you guys still do this, we had advanced lab for physics, for one of the upper division physics classes. And the advanced lab class, you would have to do some more difficult than normal, than like a general physics or phys for sci kind of level lab. And it usually didn't work for quite a while, and then you finally got it working. And then you had to go give a presentation about what you'd done, what it meant, and defend what you had done. And there was one particular professor at the time. I don't know, is he ever around the department anymore? Probably not.
Once in a while.
Bob Kingman, anybody know Bob? Well, yeah. So he, at least when I was there, always made a point of really being difficult. I mean really difficult, more difficult than anything I ever ran into in grad school, as a postdoc, or in my non-academic career. And it was fantastic. At the time you hate it, but it has meant I know how to put a presentation together, and I constantly get compliments from bosses and whoever else. Oh, you came in with a clear message, you have clear evidence behind it, and boom, 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 and we're done. Today is a little bit of a sloppy thing because this is more an informal discussion, but you will get probably good at that, especially if you spend much time in this field, either of these fields very long at all. So for me, that's been the biggest thing, I think, more than anything. Analytical skills are great, all of that thing, but understanding and then being able to communicate it to other people is an extraordinarily rare skill, very rare. I think more rare than even the analytical skills. I know a lot of smart people where I work, but I don't know very many people who can get up and talk about it in a way that anyone's going to understand. So if you have that, there's another one. So understand what you're bringing to the table, be able to explain it in 5 minutes to somebody, and you'd be surprised how quickly things come together. And some of the things you have to point out is you're not just the jack of all trades and master of none. My background, most physicists' background, is you kind of do a little bit of everything. And so people think, well, okay, you've done a little bit of everything, but you're not really good at anything. Well, that's not actually the case. Most physicists I know are jack of all trades, master of most of them, which is pretty obnoxious for everybody else to deal with. But it's true, and they love it, as long as you're not kind of, an arrogant pain in the butt about it. And of course, there's a communications perception. Everyone's watched, Big Bang Theory too much, and they think physicists are like Sheldon Cooper, and they're going to be difficult to deal with. It's not the case, right? We know that, but they don't. And so being personable, being an approachable person, being a normal person when you talk to people, big plus. All right, and so my final statement here on this subject is the world needs more physicists and mathematicians working in every kind of human endeavor. We bring unique things to the table. We do stuff, and we can, and we add value in ways nobody else does. Maybe chemists and biologists have a little piece of it, but come on, we know better, right? My wife was a chemistry major when I met her, so I always have to get old. Honestly, I mean, come on, really. I don't see enough nodding of the heads. Yeah, we do stuff other people don't do, right? I mean, seriously, we know this, right? It's okay to be a little arrogant sometimes when you're right. Yeah, and you're in a safe audience here, so. Yeah, so we've got things to bring that wouldn't be there otherwise. So we need to be out there. So if you're pursuing an academic career, that's great. And obviously the academic career is a way of prolonging and continuing the values that come here, right? All this stuff you're learning is coming because you have good teachers. And maybe you're a good teacher and you should be part of that prolonging it. But the majority, the reason we need to do this stuff is not so that we can keep doing this stuff, it's so that it provides value out there. And we have that, we really have that capability. And it's very exciting actually. It's kind of amazing. I finish my days at work pretty regularly, and I've talked to my wife or somebody, call my folks, oh yeah, this thing happened at work today, and it felt really good because I was able to do this thing that wasn't getting done otherwise. It's a pretty cool feeling. And I never expected it. Like I said, I was intending to do research. I wanted to be a particle physicist. I was, had my daydreams of being a Nobel Prize winner. I had worked for someone who's this close to the Nobel Prize. It was really exciting stuff. And then a friend of mine had been hassling me for years to come work outside at the bank. And he actually conned me into the interview. We were gonna go, car racing is one of my hobbies, and he like, oh, let's go to the car show. This was in Chicago. Okay, let's go to the car show, cool. Calls me up the night before, oh, by the way, wear a suit and bring your resume. He'd been bugging me for years, and I asked him what he did, and I thought it sounded horribly boring, and probably what he did was, honestly. But well, all right, fine. I had just been turned down by all 10 of those schools that I had applied to, so I was feeling bad or whatever. And it was a fantastic interview. 5 minutes in, I was like, this sounds pretty fun. What they wanted was somebody who could actually look at, there's an application that 85% of the Fortune 500 were using to do their treasury management. So it's all the banking for big companies, essentially, on a website. And it's 40 applications that are feeding into this website. And if anything went down, it was a problem. And an individual developer or database admin or network person or whatever, who's going to fix this? Well, database is fine. Well, network is fine. Well, my app is fine. Yeah, but it's still not working. And so they were putting together a team to go in and have that holistic approach and just rule over triage and fixing things. And I was like, well, that sounds kind of fun because you get a little bit of everything. And so I did it. It was on a Friday, and the next Monday they needed a decision. So I had a weekend to decide to change my life. And I have not regretted it at all. Maybe the first couple weeks, that was tough. They actually let me finish, I was finishing up my W Gamma paper, and they let me finish that, and I posted it in my cubicle. And it was interesting, people actually came by and read it, which I'm not even sure my physics buddies read it. But yeah, it's been a really rewarding thing. I've been there 15 years now, and I still feel like I have unique things I'm bringing to the table constantly. And I have hired a number of other physicists, other friends of mine have been hired by other people in the company, and in every case, I don't think there's any exceptions. I can't think of a single exception. In every case, when we've hired a hard science person to come in, they have been a unique contributor, a highly valued contributor, and someone who has had a very good career. So you have options, you have a lot of things that you can do. There's more stuff in this deck about how to do it. I do think that it's important for your professors, and I believe your professors here do this, are not just preparing you for the academic career path, that are preparing you for how you do the non-academic stuff too. How do you write a resume versus a CV, things like that, that's also in here. I don't want to spend too much time on that. It's more about you have value outside of academia, and I want to make sure people understand that. Because if you have that, I also happen to know, from my experience with people from the hard sciences, once they're motivated, it's going to happen. So this is mostly a motivational thing, or at least I hope so. So I think that's enough of me ranting. So any questions, comments? Yeah.
How much of your current indirect things that you want to talk
It's almost all indirect. Almost all indirect. There are some times like math and physics comes in. Math and statistics come in. But it's pretty minimal. Like, it's the simplest stuff. It's amazing, like, you know, just understanding how to look at data, and instead of just looking at an average, looking at a distribution. None of my peers has ever made a histogram. And when I make a histogram, I have to spend 10 minutes explaining what a histogram is. Right? So there is a little bit of direct stuff from my academic background. I would say almost all of it's indirect, though. Just the ability to look at stuff, ability to understand data in general. There are some things in terms of, you know, a little bit of the statistics stuff comes in. And then, of course, I don't know if you count like the programming and the IT stuff. It's not really math and physics, but it's stuff I did directly to make physics results happen. But I would call that probably more indirect. So it's almost all indirect. However, having done this, the direct stuff that you're doing now is key to having that indirect capability. You wouldn't have the indirect capability without having done the direct stuff. You're not going to just get it somewhere. And the reason I know that is nobody I know who I work with has this skill set without having sort of that hard science background. My boss is actually an engineer by training. Like I think he was environmental engineer and mechanical engineer. And I have found my bosses that I really respect and really do well all have the hard science background. So you don't get it without it. So it's a good question. It is, and actually that was something I was thinking of saying. I was just sitting in her office before I came down here, and she had a review sheet from a quantum mechanics class, and I was looking through it and I was like, I remember about half of this. So yeah, you do tend not to use all of it, but those skills, whether you're using it to do some sort of weird mathematical thing for physics or math, or you're doing some analysis of things at work that have nothing to do with those things, it's the same skill set.